Class, good morning. So this is regarding the continuation of our discussion in thermodynamics. So this is under the basic principles of thermodynamics called the pressure. What is a pressure? Okay. Pressure is force exerted by molecules in atmosphere due to gravity and temperature. Okay. So what measures this pressure? Okay, so we have manometers and barometers. So these manometers measure the pressure differential or the change in pressure between the first elevation and the second elevation. So meaning we are measuring the difference of the actual pressure and the atmospheric pressure. Another is the barometer. Barometer measures the atmospheric pressure. Okay. Another, we have the Bourdon tube that also measures the pressure. So for example, a pressure vessel and any other pressure carrying devices. Okay. From the figure as shown in A, we will notice that there is two points A and B at the same elevation. So meaning, at these 2 points A and B, the pressure are equal. Of course, the pressure at A, at the same elevation B, they have the same pressure. Okay. The barometer shown also in figure B uh, is formed by a closed tube filled with liquid mercury and a small amount of mercury vapor. Okay. Inverted in an open container of liquid mercury. Since the pressure at points A and B also are equal, a force balance gives the atmospheric pressures. As of course, the atmospheric pressure is the summation of the pressure of the column of the liquid and the pressure of the vapor above the uh, at the top of the barometer. Okay. So pressure also uh, is only based on a basic definition that the pressure is equal to the force acting on a certain area divided by the area, of course, resisting that force. Okay. So, what are the units of pressure? Okay. In English system, we have the so-called pound per square inch. If you look at the, say for example, pressure gauge, you will notice that the pressure readings there are calibrated in uh, different units. So in English, that is calibrated in PSI, and in MKS, the calibration is in kilogram force per centimeter square. But in international system of units, that is calibrated in pascals, kilopascals, or megapascals. Okay. So let us take a sample, okay, of this basic definition. P is equal to F over A. Okay, consider this problem. A 200-pound man has a total foot imprint area of 72 square inches. Determine the pressure this man exerts on the ground if, okay, A, he stands on both feet, and B, he stands on 1 foot. Okay, so let us consider the first condition, that the man weighs 200 pounds. Okay. And the total imprint area is 72 square inches. Okay, by just dividing the two values, we get a pressure of 2.778 pound per square inch. Okay, why pound per square inch? So it is because the problem is in or is given in English system. Okay, but anyway, we can change this pressure from English system to another system of units, or maybe to MKS or to SI units. Okay. The second condition is when the man exerts a force of on 1 foot only. Okay. So meaning the 72 square inches total area may be divided into two. So if we substitute that, 200 divided by 72 divided by 2 is 36. So we get a pressure of 5.56 or 0.556 pound per square inch. Okay. So this is the very basic problem. Okay, in order to apply how you are going to calculate the pressure based on the basic formula. Okay. So let us go to the other pressure conversions. Okay. So atmospheric pressure in English system, the value is 14.7 psi absolute. Okay. So there are several units used in pressure. So for different countries, okay. Like say for example, the Japanese uses the SI units. Say United States use English units. And we have also the so-called European units used by, of course, the European countries. Okay. This 14.7 psia is also equivalent to 101.325 kilopascal absolute. This is again equal to 1.03 kilogram per centimeter square absolute. This is equal to 760 millimeter of mercury absolute. Okay. Another pressure conversion is in European standard, we use the bar. Okay. 1 bar is equivalent to 100 kilopascals. And we have also the unit of pressure which is uh, defined in Tour, or this is after Torricelli. One torr is equivalent to 1 millimeter of mercury. Okay? Another, 1 megapascal is equivalent to 1 newton per millimeter square. So meaning 1 megapascal, there is a force acting on a millimeter area. Or in 1 kilopascal, we have 1 kilonewton per square meter, meaning a force of 1 kilonewton is acting on a square meter area. Okay? So this is the example of a Bourdon tube. So that measures also a pressures. Okay. Generally, pressure is represented in the following terms. Okay. So one, we have the so-called atmospheric pressure. Okay. So this atmospheric pressure, of course, is the measure of the column of gases from the atmosphere. Okay. Another is we have the so-called gauge pressure, vacuum pressure, and absolute pressure. Okay. So, but before that, we have to let us first do some exercise here. Okay. How you are going to convert pressure reading from one unit into another unit. Okay. So let us take this problem. Okay. Convert the following readings of pressure to kilopascal. Okay. A, 760 millimeter of mercury, and B, 100 psi. Okay, we are not talking for the absolute pressure here. So we are only talking the pressure conversion. Okay, A, 760 millimeter of mercury to kilopascal. Okay, from pressure conversion in the previous slides, 760 millimeter of mercury, okay, from pressure reading, we will notice that uh, 760 millimeter of mercury is equivalent to 101.325 kilopascal. That is atmospheric pressure. Okay. So, we put 760 millimeters here in order to eliminate the millimeter of mercury. Okay. So, at the numerator, we have here the denominator. So, millimeter of mercury is cancelled out. Okay. The equivalent, of course, is 101.325 kilopascal. Okay? And for B, we have 100 psi to kilopascal. Okay? Knowing also that 14.7 psi is equivalent to 101.325 kilopascals, and then we get now a value of 689.3 kilopascal. Okay? So, very simple, ano? Okay. So, let us go back to the terms in pressure. Absolute pressure represents the actual pressure at any given point in space. Actual pressure. Actual. Okay. Example of this is, say for example, we consider an air tank. Okay. an air tank with a reading of 0 psi. The question now is the air tank empty or not? Okay, of course, that air tank is filled with air, of course. But the absolute pressure is not zero. The gauge pressure reading is zero, but the absolute pressure is not zero. The absolute pressure, of course, is the same as with the value of the atmospheric pressure. Okay, so we will discuss this later. Okay, another term is the gauge pressure. Gauge pressure is the difference between the absolute pressure and atmospheric pressure. So it is essentially what you would read on a pressure gauge. Okay, so it is a relative measurement, of course. Okay, so let us now proceed to the pressure due to the column of liquid. Okay, pressure is defined in the unit to is the same is equal to the unit weight of the liquid multiplied by the pressure differential between two levels of water of liquid rather. Okay. Or the change, of course, since this is a pressure differential between two elevations, so that delta P is, of course, defined in the unit weight multiplied by the height differential or the change in elevation between the two levels of the liquid. Okay. So what is the unit of this unit weight? Of course, for water, we have here 9.81 kilonewton per cubic meter. So in MKS, so take note 9.81 kilonewton per cubic meter is in SI units. But in metric, that is 1,000 kilogram per cubic meter. And in English units, that is equivalent to 62.4 pound per cubic foot. Okay. Okay, so let us consider a problem again in calculating the change in pressure between two points. Okay. So the barometer of a mountain hiker reads 31 or 30 rather 0.150 inches of mercury absolute. That is at the beginning of hiking trip and 28.607 inches of mercury absolute at the end, neglecting the effect of altitude on local gravitational acceleration. Determine the vertical distance climbed. Assume air density was 0.075 pound per cubic foot. Okay. Solution. So the change in pressure, delta P, is equal to the unit weight of the fluid multiplied by the change in elevation. Okay. So rearranging the equation, we have delta P or divided by the unit weight. That is equal to the change in elevation. Okay, so we have already given the pressures, of course, at the beginning of the trip and at the end. So that is 30.15 and 28.607. Okay, subtracting these two pressures now and then changing this unit to make the units to be substituted consistent. Okay, so we have to change this numerator into pound per square foot unit. Okay, finally we got the change in elevation as 1455.5 or 1455.5 feet. So that is the elevation traveled by the mountain hiker. Okay. So that is the, of course, the highest elevation reached by the mountain hiker. Okay. Okay, next. We have the presentation of gauge pressure, absolute and vacuum pressure. Okay. So we will notice that at this level, the pressure is atmospheric. Okay. So let us now, considering this red arrow, so this is the actual pressure reading. Okay. So this is the sum, of course, of the gauge pressure reading here, the green arrow, and the atmospheric pressure, the blue arrow. Okay. So absolute pressure here is above the atmospheric pressure. So, but there is also an absolute pressure below the atmospheric pressure. So, let us consider this arrow here. So, this is the absolute pressure, and the green arrow is the pressure below the atmospheric pressure, or we call that as a vacuum pressure. So, anyway, the definition of the absolute pressure is just simply equal to the atmospheric pressure plus the gauge pressure. And for an absolute pressure below atmospheric pressure, that is absolute pressure equals to P atmospheric minus the P vacuum or vacuum pressure. Okay. So let us again take another example. A 51 cubic feet tank contains 3 pounds of gas at 80 degree Fahrenheit and a vacuum pressure of 24 inches of mercury. The question is, what is the absolute pressure in PSI absolute and pound per square foot absolute? Okay. So substituting the values, we have the atmospheric pressure, which is equivalent to 29.92. This is constant, minus 24 inches of mercury vacuum. Okay. So the difference, of course, is the absolute pressure, which is equivalent to 5.92 inches of mercury. Okay, so let us now change this to PSI absolute. So, again, from the pressure conversions, 5.92 inches of mercury, absolute, multiplied by, again, the atmospheric pressure, equivalent to 29.92 inches of mercury, as to 14.7 psi absolute. Okay. The equivalent now is 2.91 psi absolute. Okay. Changing this to pound per square foot absolute. Okay. So simply, by just multiplying this by 124 square inches in 1 square foot. So the equivalent now is 4,188 pound per square foot. Okay. Another example. A 30-meter vertical column of fluid, density of 1,878 kilogram per cubic meter, is located where the gravitational acceleration is 9.65 meter per second square. Find the pressure at the base of the column. Okay. So this is a hydrostatic pressure again, where the pressure is also defined in terms of the unit weight and the change in elevation. So which is 30 meters. Okay. So sa direct substitution, pressure multiplied by is equals to 1,878 kilogram per cubic meter multiplied by 9.65 meter per seconds multiplied by the change in elevation, which is 30 meters, divided by 1,000 to make it kilopascal. So the equivalent value of the pressure at the base of the column, of course, is 543.7 kilopascal. Okay. So that's all. So we have here an activity. So where you are going to solve and submit. We have quiz number 3. So we have different problems here, applying how you are going to compute the pressure on a certain uh, locations, of course. So we have here an assignment. Of course, this is the continuation of your previous assignments to make it familiarize, of course, or master how you are going to change from one unit of pressure into another, or you master how you are going to solve problems, okay, at different applications. Okay, class, thank you very much.